wasn't so much that there was a specific incident that highlighted the need for Greenlight, but rather it's the emergence of certain failures and behaviours with cables, particularly now, particularly in the most challenging conditions underground, offshore, subsea, where these cables are being jointed and terminated at voltage levels and in these kind of environments that they've never really been exposed to this before or had this challenge, and somewhat inevitably it's become a really significant engineering and commercial challenge to monitor these cables and to get ahead of these evolving trends in degradation and failure, and to allow the operators to be proactive with their maintenance to avoid them happening in the first place. Because if we don't avoid them happening, it ends up with massive loss of generation, loss of revenue, and ultimately outages for us, the customers. So this is quite interesting. Cables are not new. Obviously, we've been conducting power down cables for hundreds of years. The act of jointing and terminating cables, particularly in remote and humid environments, is new. The oil and gas industry has done this for many years, but not to the extent that's being done now with transmission power corridors and offshore wind in particular. Joints and terminations are inevitably, no matter how good the workmanship is, where the moisture gets into cables. And when it gets in, it causes a whole variety of effects. And that and other modes of degradation can stem from these joints and terminations and become a problem for the cable network. It's not that the cables themselves are in any way imperfect, or the other components that leave the factory are in any way imperfect, but when they come together in these hard environments, that's when these problems emerge, and that's exactly what we're seeing. So it's a new challenge, and there needs to be new solutions to address it. Early feedback for Greenlight has been extremely positive. What our customers are telling us is that this gives them the ability to get very high fidelity measurements of what's happening on the grid and on their cables specifically in the hardest and most remote locations where previously it wouldn't even have been cost effective at all to have data. So what they're able to do with Greenlight is gather data on these assets that is fundamentally new to them, and it is new to everyone because nobody's really been able to gather this before. So we're working in conjunction with these early customers to map out exactly how these assets perform, because some of that is known in advance and some of it is learned from this new data.
We know that operators enjoy the visibility that they get from our system. For the first time, they're able to see what's going on at every location 24/7. For a particular deployment, for a 400 kV underground cable in mainland Europe, the operator was able to see for the first time that one of their locations was deviating from normal behavior compared to other locations. So this kind of visibility has never been possible before. We can observe the significance of this deviation over time and advise when an intervention is necessary. So providing the operator with confidence and advance warning of how they do their operations maintenance. These locations are very remote, so are hard to get to. Some monitoring techniques, such as DTS, intentionally cannot monitor joints and terminations very well because the fiber is physically peeled away from those locations. However, Synaptic's point temperature sensing addresses that concern by putting sensors at exactly these critical locations. A more brute force approach involves deploying conventional sensors at each monitoring location, but the cost quickly adds up from that because you need to provision power for each of these devices and also data networks, which could be wired or wireless. That adds an extra headache, particularly for offshore systems. We know that a single termination failure on a relatively small wind farm off the coast of the UK resulted in an outage for about 1 month, costing approximately £30 million just in the lost revenue. However, the average outage time is about double that, at about 2 months. Even worse than that, the actual cost of repairing these failures is significantly higher. That's usually a total of about 65% of the total cost.